Welcome back to Syntax Grid, your go-to place for everything data science, data engineering, and machine learning. Today, we're diving into an essential concept in machine learning: decision trees. 1. Introduction to decision trees. Decision trees are supervised learning models that classify or predict outcomes by learning decision rules from features. They resemble a flowchart where each internal node represents a test on a feature, each branch represents an outcome, and each leaf node represents a class or value prediction. Example: a decision tree for, should I bring an umbrella? With decisions based on, is it cloudy? And, weather forecast says rain. 2. Structure of a decision tree. Root node. The top node representing the starting decision point. It's usually chosen based on the feature that best separates the data. Decision nodes. Points where the data splits based on features. Each branch represents a choice made on a feature value. Leaf nodes. Final nodes with no further splits, representing the output or class prediction. Each split in the tree represents a decision based on a feature, gradually narrowing down possibilities. 3. Step-by-step process of building a decision tree. Step 1: Best split. The root node is selected by evaluating which feature gives the best split. The criterion, Gini impurity or information gain, measures the quality of a split, aiming to separate data so that each group becomes more homogeneous. Step 2: Recursive splitting. After choosing the best split, the process repeats for each subset, creating child nodes. Step 3: Stopping criteria. To avoid overfitting, a tree's growth stops based on conditions like maximum depth, minimum samples at a node, or when further splits don't improve purity. 4. Data setup. Imports, loading, and splitting data. Start by preparing the data. First, import necessary libraries, like those for handling datasets and model training. Load a dataset, and divide it into training and test sets. This ensures we have one portion of the data for training the model and another portion for evaluating its performance. Example in practice. For illustration, the iris dataset is often used as a practice dataset in classification tasks. Splitting it into training and test sets allows us to assess how well the model generalizes. 5. Defining a parameter grid and using grid search. A parameter grid is a set of potential hyperparameter values, e.g., tree depth or minimum samples required at a leaf node, that could affect the model's performance. Grid search systematically tests each combination of these parameters to identify the best one. Reasoning. This tuning process is essential because decision trees can vary significantly based on hyperparameter choices. By testing different values, we ensure the model is both accurate and efficient, avoiding issues like overfitting. 6. Training and making predictions. Once the best parameters are identified, we train the final decision tree model using those settings on the training data. This creates a model optimized to classify or predict outcomes effectively. Predictions. After training, the model is applied to the test set to make predictions. The test set serves as new, unseen data, allowing us to assess the model's accuracy and validate if it generalizes well beyond the training data. 7. Visualizing the decision tree. Visualization is a key advantage of decision trees. By plotting the tree structure, we can see each decision node, the conditions that led to splits, and the outcomes at each leaf node. This structure provides insight into the model's thought process, or how it reaches conclusions. 8. Final remarks on decision trees. Pros and cons summary. Decision trees are straightforward and interpretable, ideal for both classification and regression. However, they can overfit, especially without tuning, and may show biased splits if data isn't balanced. Thanks for watching. If you enjoyed this video on decision trees, check out our machine learning playlists for more insights and tutorials. I look forward to seeing you in the next video.